This is working on number 15 from chapter 13. So the question says, a company wants you to design an open top box out of a piece of cardboard that is 17 by 24 inches. The company needs to have a volume of 400 inches, and you will construct it by cutting squares out of the corners of the cardboard in order to create flaps to fold up. How big should those squares be in order to create the box? I'm going to draw a picture here. So here's my sheet of cardboard. So we have this side is 24, this side is 17, and we're going to cut some corners so that we can fold it up and make a box. So these little corners here are X long, because we're cutting says we're going to cut a square out. So that means that this piece then is 17 minus 2x, and this piece here would be 24 minus 2x. So when we fold this box up, its length is 24 minus 2x, its width is 17 minus 2x, and its height is x, and we need that to be 400. So I'm going to do this on my calculator. So I'm going to start here by subtracting the 400 from both sides. You don't have to do it this way. You could do it with an intersection also, but I think this turns out to be a little bit easier to get the graph to look nice. Okay. So I'm going to go ahead and do this on my calculator, and I'm going to do this by graphing. So I'm going to go ahead and clear out anything that I had in my y equals. I'm going to type this in just exactly how I have it written on the piece of paper. If you wanted to waste your time and FOIL everything out, you could do that, but I think it's not necessary. It's just kind of a waste of time. And now I'm going to set a window. So if I think about this value for x, the smallest value of x we could have is 0. Right? Or since x is a length, it certainly can't be negative. And the biggest value it could really have is half of 17, right? Because if this was like 8.5 and this was 8.5, then there'd be like no width left to the box. So I'm just going to make that a little bit more than that, 9, just so it's a whole number. And my y is going to be irrelevant here. What I really just need to see is the x-intercept, because I'm looking at where it's going to be equal to 0. So I'm just going to do like -10 to +10. That's the advantage of just subtracting the 400 over and making this equation equal to 0, is that then you don't have to worry about the y min and max. You just need a -1 and a +1, so you can see where it's crossing. Okay, so I have two x-intercepts. One here and one here. Those are going to be my solutions. So I'll press second and trace, pick the 0 command. That's how we find those x-intercepts. Now the calculator is going to ask me 3 questions, a left bound, right bound, and guess. So right now my cursor is at 4.5 and 140. I'm going to move it so that it's here on the left side of this one. So I'm just going to use my left arrow to move my cursor. So now it's at 1.2 and negative, so it's down here somewhere. So that's good. I'll press enter. And I'll move my cursor to the right. So now it's 1.3, but it's positive, so it's somewhere over here. So that'll be good. And then I guess doesn't really matter. So my first answer is about 1.30. And if I look at my other solution, again, I'm going to pick the 0 command. So right now I am at 2 and 120, so I'm somewhere up here. So that'll be good. That's on the right side of this x-intercept. I just need to keep moving over until that y coordinate becomes negative again and I get on the other side. So I see it starting to go down. And there it's negative. That'll be good. And I'll press enter again for my guess. And there's my other answer, which is about 5.72. And I think if we look at this carefully, so the dimensions then of my box could be 17 minus 2 times 1.3. So there's my width. And then 24 minus 2 times 1.3. There's my length, and my height would be the 1.3. So 14.4, 21.4 by 1.3. And if I went the other way, or if I chose the other answer, which would also work, so I have a 5.6 by 12.56 by 5.72. So those are the two separate boxes that we could make, and just to kind of confirm to you, if I go ahead and multiply length by width by height, I should get a volume of approximately 400. It's not exactly 400 because we rounded those values for x. See, almost the exact same. And that's how you do that one.